Hey everybody and welcome. Today we're going to be taking a look at doing explosions. There's nothing better than doing explosions. So yeah, we're going to look at doing effects. I'm going to show you how the smoke trails were done, how the explosion was done, how the sparks were done. We're going to talk a bit about theory, how an explosion, how do you even make an explosion? How does that look like? Well, stay tuned and let's get to it. Hello everybody and welcome. In this section we're going to be taking a look at the effects, the front blast, the sparks, and the trailing smoke. I think it looks pretty cool. So we're going to take a look at how to create the setup, how to make it interact with the ship, and the whole thing. Anyway, let's jump into Houdini, where we actually have a simplified version of this that we're going to take a look, and I'm going to use this to demonstrate. So this is how it looks right now. So we have the sparks, we have the explosion, and then we have the trailing smoke happening here. And everything, you see the smoke is reacting with the ship. And everything is looking pretty cool. So this would be like a test scene. When you're doing your effects, you would create something like this just to test if everything is working fine. So before I actually give you like a rundown of this setup, I just want to quickly, for anybody who's not familiar, a lot of my friends that don't do CG or visual effects, they ask me like, how do you even do these explosions? Like what are explosions? what magic is this? How do you make something like that? So I just wanted to quickly show you guys. So we're going to use a sphere. I'm actually gonna use a mountain here. And don't worry about, all the Houdini stuff. Just want to showcase. I'm going to use the offset here. Just so it's moving like so. Now we're going to use a pyro source. You can see you have a lot of different pyro sources, a lot of different tools to use with pyro. Use a pyro source here. And we're going to we need two things initially. You can see you can already initialize smoke. So we need density and temperature. And for the mode, we're going to scatter points in our blob here. So we have this. Now we need to rasterize these points, which it's just a fancy word for saying we need to create a volume out of that. So you can see we created a little cloud here, and this cloud is essentially created out of boxes. Like if we increase this, you can start seeing these almost like pixel-like quality to them. We can even visualize it by putting a VDB tree here, and you can see the boxes that are used for this VDB representation. So these are essentially almost like pixels, and when you're talking about resolution for your explosions or your volumes, it's almost like a resolution. You just increase the number of boxes and you get a better quality. If I quickly demonstrate this on the explosion, if you go too close, you're gonna start seeing those boxes, and that's not good. You don't want to see those boxes. So the higher the resolution is, the better. In the end, when you run a more high-res sim, you kind of get rid of those boxes, and then you put some motion blur on top, and it's going to look like a simulation. Like a realistic explosion. But yeah, that's kind of a very simplified version of it. So we have this. We're going to plug that into a pyro solver. And we're going to immediately get something. So if I look at this, let it go, you will see we have a simulation running here. It doesn't look like a smoke sim yet. So in the pyro solver, you get a lot of different settings that you can change. It's actually quite a lot of them. I don't want to scare you, but you can open this as well, go inside, and this is where the actual simulation is happening. It's in this guy here, the pyro solver. Here you can input more of your forces like wind, disturbance, turbulence. I'm gonna quickly show you how to use those forces. Inside of here, this is where the solver is, and inside of here, there's even more stuff. So I know, it's science. So let's see how we can change this so it feels just a bit more like a smoke sim. So changing the dissipation will change how fast the smoke evaporates. This is here. This is where we actually add disturbances. So we can add like a bit more to break up those shapes a bit. So it actually starts getting, almost like if we would be applying some wind to our scene. And I think everything is moving up quite fast. So what I'm going to do is change the ambient temperature here. This is very similar to changing your buoyancy. So let's go up a bit higher. And I think we exaggerated our forces just a bit. Let's see, now it should look more like a smoke sim. And I think it can go up even a bit faster. Yeah, good enough. I'm quite happy with that. It doesn't have to be perfect. And you can see I am changing. I'm pretty comfortable with all of these settings. I know what they do, but for each time, if the scale of your emitter is different, the settings are going to be different as well. So if, let's say, this simulation right now is around, like if I eyeball it, it's around 10 meters in height. But that would dictate how big our shapes for our turbulence here would have to be. You can see you can change the swirl size. There's a lot of different settings for that. So each time you're doing something, depending on what you input, so depending on what our source is going to look like, that's going to change all the simulation settings. So you have to know all the settings, but then you have to adjust and still experiment each time. Just want to change the source a bit so we get a bit more random data and maybe make this go a bit faster, and you will see that will change the result quite drastically. And that's a common thing we would do to create more interesting shapes. Not interesting, but realistic shapes, or shapes that look like they actually belong in a smoke simulation. All right, so we have this. But then you would ask, what about fire? How do you get fire? How do you make something explode? And that's a very valid question to ask. To make things explode, we would need more fields, more inputs. So imagine we have density, we have temperature, but we kind of need something to ignite, to bring to almost like fuel. You need something like fuel. And in our case, that is burn. We need burn to create flames. So now that we have burn here, we are initializing burn. We have to rasterize it as well. Now, like I said, don't worry about all of the Houdini lingo. I'm just showcasing you how this is actually made. So we need to put burn here as well. And oh, look, it's already on fire. It's very helpful that we can see this in the viewport, so we can actually see that it's, fire. Now let's do something. I'm just gonna pyro bake. So this is a good way of visualizing everything after the simulation. And then in the rendering, you create a shader where you have to change even more stuff. So it's a pretty lengthy process that requires a lot of steps. So let's put fire here. Let's change it so we get something more fiery. Let's disable smoke. Here we go. We have fire. We can maybe make it even shorter like that. And we have fire. So to create fire, you would have to add even more forces, more disturbances. But you can see this is something that kind of resembles fire, like a flick of, like a fiery flame. Anyway, let's put our density back up. Remove the fire, enable scatter, and this is something you will use for explosions. can see this immediately starts to resemble an explosion. And then you can also add the fire to it. And those are the tools that we would use to create those shaders. So when I'm talking about shaders, you can essentially, you saw how if I disable this would just, we could use this just as a normal smoke simulation. And you can even change the color here. So you can use a ramp and say, oh, I want it a bit more bright here. And now we have more variation in our smoke. So now this would look like a normal smoke sim, but you can always change. You still have the data inside of here to add some fire, right? So create a fire out of this, or you know, almost something as a like an oil on fire. You would use something like this, like gasoline kind of look. So you have a lot of different ways of adjusting this look. Now, this doesn't look like an explosion yet. To create an explosion, we would have to use a different tool. And luckily, we have quite a few tools here in Houdini. It's called the pyroburst tool. So this would create something that mimics an explosion. You could create a tool like this yourself, and we do create something very similar to this in our explosion workshop. So we have this. It's just like a puffy ball right now, made out of particles. It's way too many of them, so I will just change this to 2, and I want to change the size. So I'm going to set uniform with more variation, something like that. Luckily with this tool, we get a few things for free. So we are getting temperature and burn here. I'm just going to add density to the mix, and then I'm going to say pyro simulation. And you will see it creates everything that we did before manually, but it creates it for us. So now this will actually resemble an explosion. This is initially set up to just be a fireball, but it would need other elements for it to more, to look more like an explosion. We can also change the frame duration. So let's say we put this to 8. So now the explosion will just last a bit longer. And maybe let's close the ground, so the explosion now will actually interact with our ground, and it will create like a mushroom shape going upwards. So that is something how you would create an explosion, and there's a lot more to it, but these are the basics, and that's how you would do something like that. So with all of that out of the way, let's go to our example. So first I had to scale everything down, because remember, I was telling you that the size actually matters quite a lot. So if we were here and the ship would be, 1,000 meters or maybe 2,000 meters long, that would change our simulation drastically. So let's make it, be at least 5 meters in size. Well, it's a bit more than that, but it doesn't matter. Now we have to separate the back engine and the front engine, because those are going to be our emitters. Just like we used here, a sphere, we need something to emit from. So in this case, because the engine is here, we can use the engine as our emitter. Then we blast it, we just separate it from everything else. In this case, I scatter some points on top of it, and now use that pyroburst source that we looked previously. Here, my start frame is 117, so let's go to 117. That's where the magic starts happening, and this is our source. You can see it's quite spiky, it has a lot of different shapes, and that's good because we want variety in our explosion. Then we use the pyro to rasterize everything, and then we go into the pyro solver, and that's how it looks. Well, not like that. Let's resimulate it. And here we go. I'm quite happy with that. You can see there's something happening here. And that something is our ship, which is quite important when you're having simulations, that they're actually interacting with your ship. Otherwise, what would be happening if I bring our ship here, and if I disable this part, I will just change the voxel size. So you see, this is where I was saying that you change your resolution. I will lower it in this case because I want the simulation to be calculated a bit faster. So the more pixels you have in your simulation, the more voxels, the slower it's gonna get. So you can see now our simulation is not interacting with the ship. And that's not good because it's gonna feel like it's fake. So we need to create something. And in order for this system to actually register our ship, we have to take our ship and actually convert it to those voxels again. Now our simulation is gonna know what to collide with. It's just the way it works. It's a bit technical. I'm not gonna go into it right now, but rest assured, that's how you would do it. And that's the best way to do it as well. So after you convert your simulation into voxels, you also have an attribute called V. So V stands for velocity, and velocity is essentially what you get from your ship. If we visualize velocity, there we go. So these are the velocity vectors, and they are telling the system in what direction and with what speed our ship is actually moving. And you need that data for our solver here to know how fast it should be pushing the smoke and in what direction as well. So after we do all of this, we reset the sim. Okay, so the sim has been reset, and now it's going to actually take account for all the ship's movement, and you will see the simulation is actually wrapping around the ship, and the ship is actually colliding with the simulation, and it's changing its movement as well, which, you know, like you would expect. But just so you see what kind of a setup you have to do to create something like this. And this is very common, but yeah, that's how it looks. Or smoke. We did a very similar thing here, just soloing out the front engine, scattering points. But in this case, I had to do something else to make this look convincing. I had to use a particle simulation. And a particle simulation is, just emitting points from our front engine here. You can see the front engine has a lot of points, and as it moves, it's just gonna leave a trail of points. And now we do the same thing as before, but now we transform those points into these voxel data. And it's gonna behave the same way, but now it's just gonna create smoke for us instead of creating fire or anything else. Like I showed you before, here you need those extra fields like burn and temperature to actually create fire. So in this case, we're just using temperature to move everything up, and density, which is what you're seeing right now, which is the smoke. And this is, well, it has to collide with our ship as well, right? So that's what we're doing. And you can see how the collision actually changes the trajectory of our smoke here. So you can see all of this is happening because of the ship. All of the swirliness, everything is happening. Like all of the cool shapes that you see are happening because our ship is colliding with the smoke, and that's very important. All right, cool stuff. Very cool. Now the sparks need the simulation. They need this, plus the same scattery source. Don't worry what I'm doing here. I'm just adding, well, I'm going to show you. I'm adding, you remember when I was telling you about those velocity vectors? I'm doing the same thing here, but I'm just using some code to actually manipulate it. So I can now change in which direction I want that velocity to be and to point at. So you can see I can change it like that. I just want it to be a bit like this and maybe a bit straight like that. So this velocity now we're going to use to emit our particles again. So now that we have it's the same particle system. If I quickly go inside, this is how it looks like. These are just the particles now. And because of those vectors before, our particles will know in which direction to move. So you can see they're gonna blast away in the direction of those spikes. And again, if I show you, that's our source, that's our emitter. I add the spikes, and now they're gonna move in that direction. But that's not enough. What we need to do here is actually use our explosion, or it doesn't have to be an explosion. It can also be smoke, it can be fire. In this case, it's an explosion. And this explosion also has velocities. I can show you that by doing a scatter. So creating points inside. I'm gonna do a volume trail. And I'm gonna pick velocity. So these points, well, not these trails, are representing in what direction our velocity is pointing. So in what direction our explosion is going in, and also its strength. So it's representing the direction and also the speed. All right, so when we have all of this, we can also use that data, like velocity here. I'm just singling velocity here, but it still has all of this. But it's kind of invisible. So don't worry about it, it's still here. We can still see it here in this spreadsheet. So we're using that data to additionally help push our particles. So you can see they actually move in the direction of the explosion now. So they have that initial burst, plus they are reacting to our explosion. See, they're getting pushed by our explosion and they are reacting to it, which is quite important when you have particles or any type of embers, or sparks in this case. So once we have that, we just get points, right? And points don't actually look like sparks yet. So what we have to do is trail them. Trailing is essentially just duplicating the points in a direction based on that velocity vector. So you can see I'm using that velocity vector quite a lot in a program like this, and honestly, it's used all over the place. You kind of have to know how to use them and what they're being used for to actually create effects like this. Even as something as simple as sparks can require a lot of, knowledge and just understanding of basic trigonometry. Okay, so now that we have the trail here, we can add the additional points that we created and add them and create a line between them. And that's very useful, right? Because now this actually looks like sparks. Very cool. And you can see our sparks are actually bigger where they're moving faster and smaller where they're moving slower. So that will give you a natural representation of speed in our sparks. I will resample them just to create a bit more points in between, because we have to create fiery. We have to give them some color. In this case, orange and white. And what I'm using here is, you can see in the beginning, they're quite bright, but towards the end, they get darker, and when they die off, they're completely dark. And that's also like a natural response that a spark would have. So we are doing that in this node. The way this looks like, it's something like this. Don't worry about it. And then I'm also adding noise to the sparks. Sparks would never just be completely straight, they would be crooked, and that would also add a lot to the natural feeling of our sparks. All right, so when we combine everything together, again, this is what we get. I think it looks pretty cool. All right, so now I'm gonna show you how all of that looked in my original scene. All right, cool, so here we are in the final scene. Here is my main effects, and this is the setup. So this is pretty much everything that we just did, but just a bit more complex with a bit more finessing and a bit more nodes. In most cases, I sometimes do setups like this, where it has sparks, the blast, the smoke, and the front blast in the same setup. But some people, and me included, would sometimes break this up into more nodes. So instead of having everything here, you would just create another node for sparks, and then you would just create another node, you know, so sparks, and then smoke would be here. But because when I was showing you, a lot of these effects are actually dependent on one another, I sometimes just do it like this, just for the heck of it. So the sparks here, one cool thing that I actually wanted to show you for the sparks that I didn't show you previously was I was adding these branch-like shapes. And sparks, especially when they explode, and also it depends on the type of spark and its ignition, but a lot of times they have, they don't just have noise, but they have these cool, like almost like tree-like shapes. And when you put them together like that, it actually looks pretty cool, especially when you render them. You can see they have more life to them. And if you look at a lot of real life references from how sparks actually look like, a lot of the times they're like this. Another thing, let me see. Another cool thing that I added here that I just briefly want to talk about is these sparks that explode. So when they die, they actually explode as well. And that's something that happens quite a lot in sparks as well. So when I add this on top, you can see they go like puff, 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 like that. And all of those elements will create a very, if I go to my cache here, it will create a very realistic spark system with a lot more personality than just creating simple lines or anything like that. And you can see how towards the end the sparks kind of get trapped in that wind of the simulation, and they kind of go upside. So all of that will determine how good your sparks are going to look like. You can see I'm very passionate about sparks. I actually like doing sparks, especially if they're hero sparks like that. And I do look at Star Wars quite a lot for references on how to do very cool CG sparks. The same setup is pretty much here for the front explosion. You can see it's a bit different, it's a bit more directional, a bit more stylized. That's how I intended it to look like. So we have our smoke here, and we have the explosions, and you can see how our ship is actually dragging everything with it. And that's very important because that's what makes the smoke look realistic. And you can also see I was using the density information here to make some smoke look darker and some a bit more white. And all of that will help tremendously when you're actually doing your effects. All right, cool guys. So that's it for the section about FX. Everything, well, yeah, that's pretty much it. To some of you, this might look very complex and difficult. And in the beginning, it really is. There's no simple way around this. It's a bit difficult to grasp on all of those concepts, to get your head around using vectors, detecting points. It's a bit of a learning curve, especially with Houdini, when you have, like hundreds and hundreds of nodes stacked like this together, and you don't know where to start or where to end. But trust me, once you get into this, the effects are actually the most fun to do. All right, guys. So I hope you enjoyed this section on effects. I hope you learned something new, and let's get cracking and continue with our pipeline.